Hello everyone. Today I am going to deal with the topic on measurement of length. All of us measure length, but the method that we use generally to measure the length is with the help of a meter scale. That method is known as a direct method. Now, there are different other ways to measure the length by direct method. That is, with the help of a vernier caliper, we measure small lengths in the laboratory. Similarly, we can use screw gauge to measure small lengths. If suppose the object is very big in size, then we cannot use a meter scale to measure the length of that object. For that, we use indirect method. So, the indirect methods that are involved to measure lengths are, it's called as a triangulation method. This is one method. The second method is a parallax method. The third is a laser method, radar method, and sonar method. Right? Triangulation method you have already used in maths in 10th standard while dealing with trigonometric questions. That is angle of elevation type of questions. Sonar method again you have studied in 9th standard to measure the depth of a sea or an ocean. We have used the sonar method, which is also called as a reflection method. Radar method is also a similar type of method as sonar method, which is again based on reflection technique. Right? Now here I am going to deal with the topic that is triangulation method. Now, triangulation method. This triangulation method can be used to measure the height of an accessible object as well as an inaccessible object. Now, what do we mean by an accessible object? Accessible objects means the height is such that we can measure the height of such an object. It's not very, very large. Like suppose if I take the height of a small tree, I can use the triangulation method, but if I want to measure the height of a mountain, I cannot use this method that I am explaining right now, but again triangulation method can be used but in a different way that I will be explaining here. Now, this triangulation method first I am going to deal with for an accessible object. It is for an accessible object. How to deal with the triangulation method for an accessible object? Suppose that this is a tree of which the height is to be measured. That is, AB is a tree whose height is to be measured. Now, I'll take a point at a distance x from the tree on the ground. Let us suppose that it is C. Now, this distance should be known to you. This distance is a nearer distance, not very large. This distance can be measured. Now, we will measure the angle made by this observation point. You are here. The angle made by this observation point to the top of the tree. In order to measure this angle, we use a device which is called as a sextant. Sextant is a device which is used to measure, it's an instrument which is used to measure the angle subtended by the point with the object, right? So this angle would be known to you. Now, this is the angle of elevation. Now, using the trigonometric method which you have studied in 10th standard, we can easily find out the height of the tree. Now, it's a right angle triangle. In this right angle triangle, we can take in triangle ABC. If I use the trigonometric ratio tan theta is equals to perpendicular upon base, that is AB upon BC, which can be written as H upon X. Now, you are supposed to find the value of H. My H can be equals to X tan theta. Theta would be a known value. Knowing the value of theta and X, H can be measured. Now the next method that we are going to start with is the same method but for an inaccessible object. For example, I had already told you inaccessible object means the object whose size cannot be easily measured. Suppose that I am taking this AB is a mountain. AB is a mountain whose height is to be measured, right? In order to find out the height of this mountain, I'll take 2 observation points on the ground such that C is a point, which is at a distance x from the mountain, and there is another one more observation point which is at a distance d, small d, from the first observation point. That means there are 2 observation points on the surface of the earth, right? Now we will measure the angle subtended by these points to the top of the mountain with the help of a sextant. That means suppose that this angle is θ1 and this angle is θ2. Now these angles would be known to you because we are measuring these angles with the help of a sextant. Now we'll again apply the trigonometric ratio. That is, again, it's a triangulation method only. Now in triangle ABC, I am using now cot theta. Cot θ1 is equals to base upon perpendicular, that is x by h. I will consider this as the first equation. Similarly, in a right angle triangle ABD, in this triangle cot θ2 is equals to x plus d by h, right? This would be the second equation. Now my aim is to find out h. For that, what I'll do, I'll subtract both the equations. That is, I'll subtract 1 from 2. As I subtract 1 from 2, what do I get? Cot θ2 minus cot θ1 is equals to x plus d by h minus x by h, right? That is cot θ2 minus cot θ1 is equals to x plus d minus x by h. X gets cancelled. What are you left with? Cot θ2 minus cot θ1 is equals to d by h. Now we are supposed to find out h. For finding out h can be written as d upon cot θ1 minus cot θ2. Now θ1 and θ2 are the known values. By knowing the values of θ1, θ2 and d, h can be calculated. In this way, you can find out the height of an inaccessible object. The next method that we are going to deal is the parallax method. But first I'll tell you, children, what is parallax. Suppose that if I have drawn a point, here. Now, if I look at this point by closing one of the eye, I would find a point somewhere on the board. The same point, if I close the other eye, the right eye, and see for this point, you will find that definitely there is some shift in the position of this point with respect to the board. Now that small shift in the position of this point with respect to the board, this small distance is known as parallax. That is, Parallax is the relative shift between the two observation points. That is what is known as parallax. Now we are going to deal with this method, that is the parallax method. Now this method is used to measure the distance of a planet from the Earth. A planet from the Earth. Planet, you know that these planets are at very far off distances from us. Hence, in order to find out the distance of a planet, we use this method which is known as a parallax method. Suppose that this is a planet and this is the surface of the Earth. Now we need to measure the distance of this planet from the surface of this Earth. Now for measuring it, I'll take two observation points on the surface of the Earth which are at a very far off distance. These observation points are at a very far off distance. Now I'll join these points with the planet. Suppose that this is the distance and this is the distance S which is to be measured. In order to find out that this is the planet P, in order to find out this distance, I'll consider a distant star. I'll consider a distant star. Suppose that this is a distant star S dash from this observation point. Similarly, I'll consider a distant star S dash from the observation point B also, in such a manner that the distance AS dash and distance BS dash are approximately the same. Now, suppose that now I'll join this with this point. I'll join this again with this point. This is the distance star. And we will measure the angle subtended by this distant star with this point with the help of a sextant. Suppose that this is phi 1 and this angle is phi 2. Right? Now I'll just make a perpendicular. You know that this distance is a very large distance which is equals to D. Now if this is phi 1, this would also be phi 1. Similarly, this would be phi 2. Now, you know that this distance D is very, very small as compared to S. What is S? The distance of the planet from the observation point. As D is much lesser than S, I can consider this to be an arc. I can consider this AB to be an arc. Now, if I consider AB to be an arc, AB is an arc. If I consider AB as an arc, then I'll use the formula angle is equals to arc upon radius. I'll use the formula angle is equals to arc upon radius. Now, which is the angle? Angle is phi 1 plus phi 2 is equals to the length of the arc, that is AB, which is equals to D upon radius. Radius is S. In order to find out S, S would be equals to D upon phi 1 plus phi 2. Phi 1 and phi 2 are the known values. Also, D is a known distance. By using these known values, S can be calculated easily.